Thank you very much, everyone, and welcome back to the second part of glaciers, water cycle and sea level. So if you were here this morning, we had a look at issues around the polar regions, so gaps in our understanding and what we should do about them and the priorities, which I think was a really excellent set of talks and discussion points. So for this session now, we're certainly going to start with looking at the mountain glaciers, mountain cryosphere of various kinds, and particularly the issues of water resources. So we have 4 speakers, as we had this morning, and they're all going to talk just a short talk about their area of expertise, again highlighting gaps in our understanding, what we need to do about it, and the message for the policymakers. So, actually, I'd like to ask all the speakers if they'd like to come and take a chair in front, and then we can just work through the speakers. Aparna? Is Aparna here? Ah, hi. Whatever. You can see, yep. So we could do this. So if I just introduce you, Antoine, and you can come and introduce yourself, and then we can just pass the microphone along, and you can all give your talks. So, Antoine, over to you, and do you want to introduce yourself?
Okay, thank you. So good afternoon, everybody. My name is Antoine Rabatel. I'm a glaciologist at the University of Grenoble-Alpes in France. Okay, thank you. Okay. And apparently it works. So I will talk about the need to strengthen glacier monitoring. This is important not only to understand the evolution of glaciers, not only to understand the processes at play, but also because observations are essential to feed the models that are used to project the future evolution of glaciers. So some colleagues from the University of Grenoble have contributed to this presentation also. I will not mention everybody, but at least my colleague Delphine Six, head of a Glacial Climate Observatory, who finally could not attend this meeting today. So why do mountain glaciers matter? Yes, okay. Why do they matter? We had several examples in the morning. I will go a bit quickly, not much into detail with it. So obviously they are very good sentinels of climate change. By essence, the glacial geometry evolves with climate condition, and you have here nice pictures of the Mer de Glace, an emblematic glacier in the French Alps, with 1 century apart between the 2 pictures. Regarding sea level, it has been mentioned several times in the morning, mostly regarding the contribution of ice sheets. The ice is contributing 45%, and within this 45%, glaciers are about the half, which correspond to about 1 millimeter per year in the last decades, and their contribution will likely be equal to the one of the ice sheet until the half of the 21st century. Regarding water resources also, on this map you can see the contribution of mountain cryosphere in the glaciological regime of high mountain watersheds. So the glacial contribution is shown with the light blue color, and the other part of the circle is the rainfall contribution. So you can see that this contribution is really different depending on the region of the world, and in many places the glacial contribution is the most important. And we know that the peak water, this means the most important contribution of glacier, has already been passed or will be passed by the mid of this century in most of the mountain catchments. So obviously this will have implications for agriculture, water consumption, and hydropower generation. Regarding mountain hazards, it has also been mentioned in the morning, with example in Nepal, regarding gloves. And here I show an example of a famous event, unfortunately famous event in Peru with Lake Palcacocha, an event which occurred in 1941, and with more than 10,000 people who died. And finally, because of biodiversity, so in the previous session, we had a talk by Jean-Baptiste Bosson emphasizing on this. And I illustrate this with some pictures on the Bolivian Cordillera Real with a program Life Without Ice, which has been also mentioned in the former session regarding the biodiversity of a glaciarized environment. So which is really specific and need to be carefully studied. So why should we care? First of all, because we know that annual glacier mass balance is becoming increasingly negative year after year. This is illustrated by this bar chart on the left, so which is a summary of the reference glaciers that are monitored with in situ measurement all over the world. And so this graph covered the last 7 decades, I would say, and you can see with the red bars which are more and more big, that the mass loss is increasingly negative. And on the right side, you can see this illustration. So it's not the same ice cube as the one shown by Andy Shepard in the morning. This is only the mass loss of mountain glaciers in 2022 in European Alps, which is close to 5 cubic kilometers. We should also care because we have been able, thanks to satellite observation, to quantify the mass loss of mountain glaciers all over the world. This work has been mostly done thanks to satellite data from the Aster platform, which will end in a few years. And unfortunately, there will we will not have a continuity for this mission. So it's a big loss. I will come back to this later on. And on this map, you can see how diverse is the mass loss all over the world, and I want to emphasize the use of satellite data to to be able to quantify the spatial variability. And if we zoom in into Europe, Caucasus, and the low latitude, you can see that over the last 2 decades, glaciers in this region have lost more than 25% and up to 33% of their volume of the beginning of the millennium in the European Alps. So it's quite important. I also want to highlight what is for me maybe the biggest unknown we have now for mountain glaciers. So obviously their total volume is uncertain, but maybe more important is the knowledge we have regarding ice thickness distribution. And the most recent study have shown very important differences. I illustrate here with the Academy of Science ice cap in the Russian Arctic, and you can see with the 2 pictures. On the left, the last study by Romain Mian and collaborators, and on the right, the consensus estimate in 2019 by Daniel Fainotti and colleagues, that depending on the way we model the ice thickness, the representation can strongly differ. And this is really crucial because an accurate representation is essential for initializing the models for the future projection. So we really need to continue working on that and to improve our capacity to know this glacier thickness distribution. So some key priorities to strengthen monitoring networks. One is obviously long-term monitoring, which is essential. Indeed, with this graph I show with the glacier de Saint-Sorlin in the French Alps, an example of 2, let's say, 10 to 15-year periods of observation in the past, where the glacier was quite stable in terms of mass evolution. And if you only have short term, maybe you have a biased perception because the big picture may strongly differ from short-term periods. And it's a bit the same comparing local scales to global scale changes, and so strengthening monitoring networks also means both local to large scale monitoring, so with combined observations. And I illustrate this example with maybe the last glacier who is gaining volume during the last decade. This one is located in Patagonia, Glacier Pio-11 over the period 2020-2019. So I show here the thickening of this glacier, which is illustrated in blue on the map. But this specific behavior may strongly differ from the big picture, and you can see here where this Pio 11 glacier is located within the southern Patagonian ice field, and you can see with the red colors that all other glaciers are thinning over the same period. So strengthening monitoring means commitment, coordination, and strategy, and there is a need for a combined approach between in-situ observation, which are mandatory to document the temporal variability, and with satellite approaches, satellite observation, which are useful to document the global scales. And there is also a need in the continuity of this observation and on the satellite mission, which is very important. Commitments mean also people, technicians, obviously, engineers and researchers. This means capacity building, particularly for low-income countries, I would say. And from my point of view, this also means permanent position because we need this long-term perspective. This also needs tools, investment, and technology because we are working in harsh environments and because the material and the people are facing very harsh conditions. And finally, this means also coordination, strategy, and structure and institution at different levels. I illustrate here two of this level, the international one, where we have some international association like Ajax. We had a presentation in the morning by Liz Andreasen, and we also have other kind of a structure like the Global Terrestrial Network for Glacier with the World Glacier Monitoring Service, with the GLIMS initiative hosted at NSIDC in Boulder, Colorado. And this international level is really important to gather the data collected at global scale and also to structure some working group within the community. But unfortunately, I would say, this work is mostly based on volunteering. And so we really need more fundings to encourage this work and to go a bit further. And at the national level, I will take the example of the structure we have in France. So in France, we have this glacier climate observatory, which is present not only in France, but also in the Andes, in Himalaya, in Antarctica. And this is, for me, really important that this observatory is funding with public money, and also which is recurring, and all the data are open. And my last slide to promote what is maybe unique at global scale in France is the CNAP, which is a corps of staff specifically dedicated to observation in astronomy since the 19th century, in geoscience or earth science, and since the beginning of this millennium, since 2002, with the Observatory of the Environment, like Glacial. And from my point of view, this really needs to be promoted. Thank you for your attention.
Okay, thank you. Good afternoon. My name is Jefferson Simões. I'm a professor of glaciology and polar geography in the southmost of Brazil, and also head of the Brazilian National Institute for Cryospheric Research. And presently, I'm one of the SCAR vice president. As a tropical man, I'm going to talk a little bit about tropical glaciers. So I'm not talking about Antarctica, I'm talking about glaciers in the Andes, and how is all connected, and we are talking about melting of glaciers from the Patagonia to the tropics. And the first question, well, why does it matter? It's interesting that a lot of times when we are discussing environment changes, climate changes at the global sense, if you go around to scientific papers, media coverage and so on, it's quite a lot concentrated in the tropics, sometimes in the temperate regions. And we forget the cryosphere, 10% of this world, the surface. And the tropical glaciers in particular, the ones that are in great part, about 90% in Peru, and also something in Bolivia and Ecuador, are extremely sensitive to small changes of temperature. They melt very fast. They are an important source of water, and in fact they stabilize the water flow during the dry seasons of the year. And besides that, as we have seen this morning in relation to the Himalayas, it's particular. It repeats itself with some natural hazards, having landslides and glacial like outbursts, floods. We know in the past we have observed several extreme events, killing thousands of people in sometimes 15, 20 minutes when we have these floods. And of course, we cannot forget the scenic beauty, the tourism potential of these areas. So, what to know? What to know from the IPCC reports? And before that, we had the special IPCC report of 2019 for cryosphere oceans. But we know, of course, that it's a widespread melting for the last 120, 140 years, but it has increased substantially for the last 4 decades, particularly in the Peruvian and Bolivian areas. One of is small, it's a symbolic glacier, I would say, because it has gone completely. It was the small Chacataya glacier that had, in fact, the highest snow skiing station. It has gone totally. And the number of natural disasters are about to increase, and more important is that several of the cities in the Andes depend on the water resources during the dry seasons. Just I can give you an example, La Paz, the capital of Bolivia, it has between 15 to 20% of water coming from the glaciers. And we are already seeing the reduction of agricultural production due to the shortage of the water coming from these glaciers, particularly because the peak of melting in some of those glaciers that provide water to the cities has already gone. And from now onwards, we are going to have shortage in the water storage. And we cannot forget, and as I work with ice core, and that was one of the main motives that Jérôme and colleagues created the ice memory, is that we are losing a lot of the ice core records in those mountains, not only in the Andes. All mountains are gone and are disappearing. So, we had in the past landslides and glacial lake outburst floods, and glaciers has reduced by 40. Oh, sorry. Our projections say that we are going to lose about 40% of the ice cover of the Andes. That is included not just the tropical, but also the temperate glaciers, the ice fields of the Patagonian, and that is, as you can see from the photo in the corner, for you, it's the left. The left corner is the Uppsala Glacier in the Patagonia ice field. We have a general retreat of glaciers to the eastern part of the Patagonia ice fields. And but what is new? It should not come as a surprise that for the last 5 years we began to see the impact of. Is there a point here? No? Okay. My point is my finger then. Besides seeing a reduction of snow precipitation accumulation in the Chilean and the central western Argentina Andes, one thing that's calling quite attention is the increase of biomass burning in the western part of the Amazon forest, and that is create plumes of black carbon. We can see that sometimes those plumes can go straight to the Pacific Ocean, but more important, a lot of the black carbon deposit over the Bolivian and mainly the Peruvian glaciers. And of course that increase the albedo of the surface of the glaciers and therefore increase the melting. We are seeing, unfortunately, this kind of changes at the surface of those glaciers. What's the main message then from here? What we can say? Of course, rapid reduction of snow and ice has been observed and is inevitable that we are going to lose ice masses even if we have just 1.5 or 2 Celsius degrees of global warming until 2100. Natural disasters are, all predictions says that we are going to have more glacial lake outbursts, and we need to investigate how the changes in the Amazon forest, both the biomass burning, but also the deforestation, and now we just give it's news from the last couple of weeks. We began to have some kind of sand mobilization because of a strong drought in the Amazon drainage basin, and that's going to Eastern Andes as well. And but most important is the seasonal water scarcity that we are seeing in some of the cities, valleys of the Peruvian Andes, and there are places that are red, showing a reduction in the production of agriculture. And then we have other consequences like the tourism potential. Finally, I think that our main message for all this meeting, and I'm going to say that as a scientist coming from a tropical country, that it's a simple statement, but it's appalling that people don't recognize that all environment system is connected. I can say that in the past we had too much emphasis in the tropics, too much emphasis in the Amazon rainforest. I'm not saying that's not important, it's the contrary, but we forget that 10% of the world is ice covered, and that's changed very fast. Thank you for the attention.
Thank you. So I'm Dr. Aparna Shukla from Indian Ministry of Earth Sciences. And as the slides come, let me just introduce myself. So I also look after, I'm a geologist, a glaciologist, specializing in glaciology. And I also look after the activities of the National Center for Polar and Ocean Research in India, that is NCPOR. Which is an institute mandated to look after all the polar expeditions of India. Now, with this, I also thank the organizers for having me, and also my previous speakers, because they have made my job a lot easy, because I completely endorse what my previous speakers have said. It's just that I'll be presenting the perspective from the Himalayas. So today I'll be talking about issues and key priorities with regard to the Himalayan glaciers and climate change. So coming to the area we're talking about, that is the Hindu Kush Karakoram Himalayas, or also it is sometimes known as the high mountain Asia, when some of the northern regions are also included. So as the previous speakers have also said, that why the changing cryosphere is important to us. In general, and in terms of especially Himalayan cryosphere, the changing cryosphere is important to us, basically because stemming from these 5 points which I've mentioned here. First and foremost, because of the water security in this region, because all the Himalayan rivers which are emanating from this region are basically snow and glacier fed, and they are basically the lifeline of the population which lives in the floodplains. Then secondly, because of the hydropower generation, it is, the hydropower generation, or, electricity generation in general, has a heavy dependence on water availability. So any kind of electricity generation in this region, approximately 83% of electricity generation in this region is heavily dependent on water availability, be it hydropower or any other source. Then, in the wake of the climate change, as the extreme events are becoming more frequent, that puts these areas, the mountainous areas, the glaciated areas, more vulnerable, because as we have seen, and speakers early this morning, I think the one from EC Mode, they have also emphasized that the hazards, the glacial hazards have again become very, very important, and that is how, the changing cryosphere is important to us. And lastly, but most importantly, India has a very vast coastline. That's how we are also interested in and affected by the contributions which the melting cryosphere is making into the sea level rise, and the consequences which come from that. So despite this, the recent estimates which show us, the mass balance estimates, from various, what has been reported from various workers, they persistently show a negative trend, as Dr. Rabatel also mentioned, that, the glaciers across the world and also in Himalayas have been showing a, persistent negative trend. So this is, these are the reasons enough for us to act. Now, coming to what is important, and what is new and what is changing fast. So in terms of, mountain glaciers, and specifically in terms of Himalayan glaciers, the climate change impact on small mountain glaciers is very, very important and critical. This is because as the mountain glaciers start to respond to climate change, what happens is that first they start, kind of fragmenting. The large glaciers, they start fragmenting into smaller glaciers. And smaller glaciers have been reported worldwide to be more, vulnerable and, more sensitive to the climate change. And on the verge, some areas have, reported the complete disappearance of the small glaciers. In this regard, I can show one example, a study we carried out in one of the basin in the Western Himalaya, which has a predominance of the small glaciers, as we can see in the pie charts, that this basin, which is a Suru sub-basin, has predominantly, say, more than 60% of the glaciers which are less than 3 kilometers. And on the other side, we can see partial distribution of the mass balance estimates. The range of the temporal duration of this was around, I think, 18 years, 2000 to 2018. And we can see that, most of the small glaciers have been, very strongly, having a very strong negative mass balance as compared to the large and medium ones. So, these small glaciers are much vulnerable, and they need proper monitoring. Then, the climate change and thawing of the permafrost is again an important issue, but we'll not talk, I think, in detail about that, because there is a complete session on this afterwards. Then the other point is that glaciers associated with lakes and lakes associated with glaciers, these again need much importance. Why? Because is that whenever there is a lake which develops on the surface of the glacier, then it becomes actually a hotspot of melting. It absorbs more heat as compared to the surrounding ice, and in that process it starts melting the ice which surrounds that. And there develops a feedback process, so that as the lake expands, it induces the glacier, the parent glacier, to reduce fast or retreat fast, and that retreating glacier, it adds to the water volume of the glacial lake, and the increasing volume in the glacial lake is and can be very, very dangerous. It can pose the risk of glacial lake outburst plus, and in case of supraglacial lakes, these lakes may coalesce to form bigger lakes. So again, this is a very important point which we need to be wary of. Then in terms of the glacial lakes, this is a recent study which shows that in the high mountain Asia, which shows that, which projects in terms that the areas where new glacial lakes may form in future. So this is again, as we can say, the small blue circles, they are the projected areas where new glacial lakes may form. So this scenario doesn't look very good. Next, what is still missing in our understanding, and I think most of the points have already been covered significantly by our previous speakers regarding the ice thickness estimation, the in situ measurements. I think the speaker in the morning from ICMO talked about length and emphasized that in situ measurements and long-term measurements are what we need. Then the glacial hazards, as I've been talking about, that glacial hazards again at different stages and different areas needs to be tackled. But what I like to add is about the debris-covered glaciers. Now, debris-covered glaciers, they cover around 12 to 13% of the glaciers in the high mountain Asia. And the response to the response of debris-covered glaciers, or the behavior of debris-covered glaciers, is completely different with, as compared to the clean glaciers. This is because of the presence of debris cover, which depending upon its thickness, may insulate or accelerate the ablation. So that makes them differ from the clean glaciers, and they need to be studied thoroughly in that regard. Now, this is an example of measurements done on the debris-covered glacier in the Western Himalaya. This has been done by the NCPOR, that is National Center for Polar and Ocean Research. And this is part of their long-term study in this basin. So the National Center of Polar and Oceans Research has been carrying out long-term studies in the Chandra Basin of Western Himalaya, where they have taken 5 benchmark glaciers, which they have been monitoring now for a decade. Several parameters they've been monitoring, in situ measurements. And also, for basin scale studies, they have been using the satellite data for estimation of different parameters. And most importantly, here we can see the Ostrom curve, which is the curve between the ablation and the debris thickness, which clearly shows that how debris thickness is, reducing the ablation rate. That is, near the snout, the ablation rate is almost, very low. And the maximum ablation rate in this glacier is basically near the upper ablation, which is just the reverse the case of a clean glacier. So this is how, the debris-covered glaciers are important. And in terms of debris-covered glaciers, again, there are several aspects of debris-covered glaciers which are important. As I have mentioned here, related to the debris generation, then quantification of the debris properties, then affinity of debris covers, ice cliffs and supraglacial ponds, then their behavior, their hydrology, their behavior to climate change. And in each of these areas, there are some important questions, which are there, which are being progressively answered by the studies which are being carried out, but still we need to do more in these regards, because understanding is still not comprehensive in this. Now, coming to my last slide, that is the key priorities for action and message for the head of the states. The key priorities, as all of the speakers who have talked about mountain glaciers have been emphasizing, that long-term monitoring basin scale glaciology observations are very, very important. Then we need to accelerate research in the identified gap areas, and then capacity building and involving the young researchers is again very, very important, because That's how we have to, that's the only way we can sustain, these studies. Then the message for our head of states, we have basically 4 points. That is, enhancing the international collaborations towards, accelerating the research in the gap areas, as I already told. Then creating awareness again, related to these issues. This is again very important because, a sizable population is not aware of these situations. Then creating, channelizing funds and creating opportunities. Again, this is, I think, of prime importance. And lastly, to organize more such events as this summit, which are across sectors, across, what I'll say, trades, so that, we can really act on what is needed. Thank you.
Well, it's my pleasure to be here. I'm from China. Later, I just show what's my name. If I just speak, you never remember. If I put my slides, you will see it. Okay, so thanks, Jeremy, and thanks all of the audience. Let's wait for, oh, it's coming. Okay. It's my first one? Yeah, I just try. Yeah, that's my name. Okay, so my talk focuses on the third pole. So right now we said Tibetan Plateau, even a high mountain Asian, we said third pole that compared with our south pole and north pole. But I'm not sure people agree or not, but that's really a pole. It's high elevation pole. Okay, so my name is Shichang Kang from State Key Laboratory of Atmospheric Science. And also, right now I'm director of this laboratory. Also, I'm deputy director of this institute called Northwestern Institute of Eco-Environment and Resources, Chinese Academy of Sciences. So my talk focuses on the third pole. Why third pole is very important? Because when you look at it globally, look at it everywhere, we so-called the water tower. Only the third pole is a very strong function for the water tower. That's why, of course, Andes is very important. And also the Europe, Alps, also very important. But third pole has very high index for the water tower or water resources. Okay, so here's the west of China, but of course including the third pole at Tian Shan, at Central Asia. So the Chinese colleagues, we established many monitoring stations over there, and the longest one started 70 years ago, which we so-called the #1 glacier in Tian Shan. That's also the one of benchmarked glaciers globally. So we will see we have more density observation compared to the Antarctic and Arctic, especially Antarctic ice sheet. I love these photos. You know why? Because 100 years ago, the British explorer, they took these photos from the northern face of the Mount Everest. So this year, 2023, my group, of course I'm in the field too, I've been to Mount Everest high elevation 12 times. I never said the base camp, because base camp is a tourist place. Many people just drive out there. We worked in the high elevation, even 6,000, 7,000 meter sea level. We're drilling ice cores, doing the observation. So during the last 100 years, look at the changes of the glacier, of the Rumbu Glacier. That's of course, in the other side, we said the Khumbu Glacier. You may be very familiar with the Khumbu Glacier, but this Rumbu Glacier is also quite famous if you climbing in the northern face to the Mount Everest. Well, we have different source. This right here, I just list the glacier, within China. I didn't include in the Hindu Kush and other place. Within China, because China finished the second glacier inventory, we will release the third glacier inventory very soon. And in the next half years, we will release the third one. That's also the very fast countries for doing the glacial inventory. Of course, inventory is not only the area change, mass balance change, the different parameters, the individual glaciers one by one. So right one, you will see also we have a different the mass balance. And also another source, you see, the left one is mass balance, it's going down. And also right one, even each year now we lose the glacial as a mass balance over 1 meters in the southern part. Of course, in the Karakoram, it's less. This morning, also our colleagues introduced. So this is another one. At least our assessment showing that each year in the third pole, we almost lose 20 gigaton per year. So that's a 10% of the, compared with the Antarctic. Just remember the numbers. Okay, I also like this one. Just look. Why? Why the water just come from the center of glacier? Why? That's the internal melt. Because if usually when the glacier melts in the surface, they just the stream going down, just like this morning some people showed. And also, sometimes the meltwater penetrates down to the bedrock, then we come out to the front of the tongue of the glacier. But this one exactly from the center of glacier, that's because inside of the glacier, they also start melting, very strong melting. They have the internal hydrological system. We observed many glaciers, but I don't know the left one, but the right one is exactly Gonga Mountain. So that's not the avalanche, slow avalanche. That's the water and the slow pour down from the accumulation region. So this is a kind of a tip point. Because in the upper glacier, stronger melt and water accumulated and they pour down with slow. So this flood is not only the regular glacier melt, but we inside because we observe all of those things. Okay, so glacier melt water. What is happening? So for the third pole regions, we will see the left one and the right one. So during the past decades, we will see the glacier meltwater increase, but it will change. It will change. In the different regions, some place peak water has gone, has finished, has passed, and that's why because in the river basin, if you have a small size glacier with small size, the peak water already passed. So in some basin, of course that's Chinese, but you will see some increase, some decrease. So which means increased basins with large size of glacier, but decreased with small one. Here is also in the future projection, the glacial water, meltwater will decrease, definitely in everywhere. But we also have this peak water. You see left side, we have peak water 2022 to 23 with the green one. You see with the green one, the red one means peak water has passed. The blue one will be 2050. So that's for the hydrology impact. Okay, permafrost. I believe this section will be the other section, but I just introduce. The permafrost area decreased. That's the numbers right there. The numbers area decrease. Again, the active layer thickness increase. Why? Because warming. That's increase with air temperature, and also the soil temperature increase. Those are all data we observed in the third pole right there. So you don't need to remember that numbers, but remember, look at over there, the stubble cast and all of those permafrost degradation happen because we usually say permafrost temperature increase. That's a little bit slow one, but the degradation, we say the rapid degradation, you will see lots of stubble cast and stubble sowing place. And also we do a statistic, look at the right one, you will see since this century, 2008 to 2021, we have more sowing place. We have more sowing areas. That's definitely this kind of geohazards happen, which impact the highway, railway, because in the third pole, and also the land stability. Well, this is stubble cast lakes. Also, stubble cast lakes increased from later one, like 1980s to look at 2020, and last decades increased a lot for the stubble cast lake. For the snow cover, also decreased. I have two sentences said. One is snow cover mainly distributed in the mountain regions. Second one is snow depths and snow cover days decreased during last 40 years. Well, that's last my point is black carbon, is atmospheric pollutants compared with the cryospheric change. So we established many stations, over 30 stations to check through. And you see, in the different regions, we collect slow samples doing the black carbon measurements. And we see the black carbon distributedly. And again, black carbon could reduce albedo from 10% to 50% because albedo is the key point for glacier melt to absorb the solar radiations. So this is very obvious. And also, due to the black carbon darkening the glacial surface, and then the 20 to 40% accelerated melt. So you can calculate. You do the observation, you can calculate. So how could we do that? This is another way. Black carbon directly deposits over the glacier, darkening the glacial surface, and accelerate glacier melt. And the second one is very interesting. We also calculate the black carbon in South Asian Indo-Ganges plain, and we found that due to the black carbon, the precipitation increased in South Asian, so that decrease the precipitation in the southern Tibetan Plateau, and in that case, glacier has less mass gain and a stronger mass loss, so make the more negative mass balance. So this so-called the black carbon direct and indirect impact of the glacier mass balance. This is for the snow cover. Snow cover is the same situation with glacier because darkening snow surface caused by black carbon and also speed up the snow melt. Okay, so that's my message. I mean, I'm not going to repeat. Our colleagues already talked about the monetary international collaborations, but only focus on the regional problem. So regional problem is black carbon from the Asian is not really bigger contribute to the Arctic and Antarctic, but for the Asian, for the Himalayan. So that's why it's even up to 20 to 40%. And again, black carbon cannot be insoluble. So when the glacier melt, they accumulated darkening, glacier melt, more darkening, more speed up glacier melt. So that's the positive feedback. Okay, right here, what we propose, two sentences. If we reduce the black carbon in the future, it will increase air quality in the ocean, air quality. Second one, it can protect our water tower. So that's my message. So thank you very much.
Thank you very much to all our speakers, and it's quite amazing the different kind of approach to the sort of large-scale glaciers of the polar regions. But here we've got, you know, people involved in water supply and quite a consistent story across the different regions, and black carbon, which hadn't occurred to me so much. Any questions for our speakers? Yes, sorry, there's a lady there. Or
Hi, hello everyone. Thanks for the presentation. I'm Beatriz from Peru, who talk about our glaciers. So we have lost more than 50% of our glaciers by now. And I'm agree with all the comments and all the facts that you share with us, but we have a problem with quality of water. And anyone mentioned that what is related with acid rock drainage, related with the rocks, the base rock, who expose when the glacier is retreat. So I don't know if in any of your countries or your experience have the same problem, because that's a huge problem for us. We have many people who depend of this water, and it's not only that the climate change reduce the quantity of water, is reducing the quality of the water. Thanks.
who would like to answer that one? Jefferson, it's your area. Here, have. This one's working.
Thank you. I really don't work with the quality of water, but I know about the load of sediments increasing. That brings another question also, how is going to affect not just the quality, but also the sediments go towards dams, and that it's another problem for hydroelectric dams, and how it's going to fulfill of sediments. And I don't know if you have particular numbers of the way that is changed the chemistry of the water, and of course it depends a lot on the lithology, where the water is going through, and yeah, it's another problem.
Yes, actually, the glacier melt, not only the quantity, but the quality for the water resources. Because historically, it stored the pollutants, let's say pulps, heavy metal, mercury, all of those guys be released again. We saw the second pollution after glacier melt. Of course, virus. Microbial community, there's still virus. We already checked that. Of course, permafrost really have dangerous things, but for the glacier, also including some guys, we need to check. We are started doing that. We didn't say that is because we don't want the public get panic.
Just about to forget. And there is the question of partial elution. It depends on a lot on if you have acid precipitation over the glaciers. If you have partial elution, when it begins to melt, of course, Age plus goes first. And you, at the end, you have acid shock in the lakes. That's something that happened quite a lot in the Scandinavia in the past, with the snow cover melting and having a acid shock in the spring. The great question is how we are going to change that. And of course, you have the other problem of mining, and they have metals in Peru and Bolivia, even more serious.
Michael Tremp, Work Glacier Monitoring Service. I would like to come back to something mentioned by Andy this morning about gaps in satellite observation. So you mentioned the gap between cryosat and crystal that we might face. Antoine mentioned the decommission of Oster. We might run into a gap of high resolution stereo optical satellites. So in view of the message to the policy, taking over some of the long-term monitoring that we're going to need. And the question is to you, is this something that is captured already in the messages to the policymakers?
No, that's a very, very good question, and I think I take it as a kind of an aspect we didn't really stress so far in the declaration, but that's a very, very good point. I think we didn't get to realize what was going on with this question of a satellite survey of the cryosphere. So we take the point. Thank you very much.
Thank you all for a very interesting presentation. I'm interested in our Chinese colleague, if he can tell us what the reaction of your government and the regulators has been to all this information about black carbon and so forth. Because I'm an NGO, and in the context in which I work, which is Antarctica mainly and the oceans, we have a very hard time convincing many countries, including China, to listen to the scientists. So your experiences there on this set of issues could be very valuable for international work. Thank you.
Thank you very much. Actually, since after 2000, China reduced lots of pollutants. Yeah, you're right. It's probably the history, but currently we collect data, we do compare different countries, the emission from different countries, not only from black carbon, but also for the other particles, which live one more. After 2000, we in China also the temperature decrease, so decrease. But the South Asian still increase. So that's why we are worried about it, because China, I think you are saying the history. Currently, they listen to us. They really listen to us. They thought, okay, yes, we need the clean mountain, clean water. That's the president just said. Of course, they listen to us. So black carbon goes down last decade, but surrounding countries still increase. We talked this many with ECMOD, our international institute. This is a very open talk about in the future decrease that. I think one thing I didn't mention is we also tell the government we need to protect the glacier. And another word, mitigation. They said, oh yes, well, what we should do? Artificial slowing. They said, yes, we support you, project. That's very good. In the mountain regions, we try to do the artificial slowing. They even support the findings. We are trying to how to mitigate or reduce accelerated glacier melt. That's all of those measurements that recently they really listen to the scientists what they said.
Good afternoon, Rodika Nitu from the World Meteorological Organization with the Global Cryosphere Watch. And I have a question for the speakers, two-part question. One, I heard your results, tremendous effort at national level for the monitoring of glaciers. The question is, in the context of the preparation of the declaration, what would you like to see from a policy point of view at the national and international level to ensure the sustainability of efforts that you are conducting for the long-term monitoring of glaciers? Because the short-term projects, whether 3, 5 years, are not sufficient to collect the information that you need. And the second aspect is that related to the access to data that you are collecting. And how would you assess the ability and the needs for greater access to the data available such that new knowledge is developed based on the data that already exists? Thank you.
Yes. Yes, so the first part, that is how we would like to, how the governments should act to, perpetuate the long-term studies. So as I told that the National Center for Polar and Ocean Research in India, which is mandated to carry out all the polar expeditions, including Himalaya, has a very strong, polar program, but also it has a very, strong program in the Himalayan glaciers. And they started in 2013, and now they have almost 10 years of data. And this data set and these observations are restricted to the Western Himalayas, but we are trying to expand in both the in the other areas as well. And government we have the full support of the government, because they and we all understand the impact of long-term studies, as all the speakers have also emphasized enough. Then the second part which you asked is data sharing. So data sharing is that, like, whatever work which has been done by NCPR or by the Indian scientists is very well published, and more effectively, if it is written to us, then the data can be shared and there is no issue, and it is well recognized that sharing of data is among the best practices, and we need to follow that. Yeah.
So thank you. Well, regarding the long-term monitoring, I think that the engagement of government needs to be promoted, I would say. From my point of view, it's the only way we can have a long-term perspective, because with project funded, you still need to be innovative, you still need to try to push something forward, and observation needs continuity. Also in the way we are doing the measurements. You cannot measure ablation in one way during 5 years and after change the way you measure it, because it will not be comparable. So you need this long-term commitment, which from my point of view can mostly come from states, from government. On the other side, we have some international initiative. I would take the example of the GLIMS initiative, which globally gather all the glacier inventories. So you have access, open data for everybody, every scientist, every citizen, to the multi-temporal inventory of glacier all over the world. And this initiative concretely is on the shoulder of one person. The one who managed the database, Bruce Rope, a colleague in Boulder, Colorado. And when he will be retired, we don't know if this initiative will continue. So this really need to be tackled, and I think we need to have a community engagement to promote these initiatives.
Well, I think for the long-term observation, different country has different support way. At least in China, we have the station. What we say station means could be supported by the state, or supported by institute, or supported by the CAS. So in that case, at least for our lab, from our lab, we already have more than 10 stations, which not only depend on the project, but has a fixed support each year. So that's the first one. I think different countries, they have different policy. Second one is data sharing. Like our glacier, we have a write-off glacier inventory. You can share that. And also we have the mass balance. Also you can share that. I think my worry is sometimes the data released a little bit late. So a little bit late. So good things, any kind of data when you publish, the journal requests you must publish data. So in that case, nowadays, as long as paper published, we can we can get the data, we can do the comparison. But of course, our glacial community has very good groups to organize the mass balance at the glacial inventory, right of glacial inventory. Thank you.
Yeah, a question following the presentation of Chichang. I was impressed by your measurement that peak melt was observed in many catchment areas. Can you elaborate about the question of adaptation after that? Are there lessons to take on how possibly the local population, I mean the local policymakers, adapted to the fact that you are on a long-term trend of losing meltwater, and that could extend possibly to the Andes or, yeah, and other speakers?
Oh, yeah, that's very good, because not only the Himalaya, but also the Tian Shan, Xilian Mountains, the desert regions totally depend on the waters from the mountain regions, not only the glacial, but also the snow cover, even the thawing permafrost. So policymakers quite understand. We already introduced, we said, okay, you see, right now, we probably have more waters, but in 2030 or 2050, we will decrease. Yes, they understand that. So now it's very interesting things that before the glacial observation and glacial survey done by scientists, now the state, they think the glacial is the resource. Of course, resource, but now they accept that. So in that case, there was a couple of, we so-called Ministry of the Natural Resources. They including the glacial as a resources. That's really good for us because they also focus on or take efforts to do the observation or even doing the investigation. But sometimes they don't release the data. But anyway, scientists is very happy they accept our knowledges about the resources. Before they said, okay, glacier is very small, it's just far away. But when you look at the arid regions, there's really valuable waters. So that's my answer.
Thank you very much. And one more question? Yes, and then we must finish because I think there's another session here.
Quickly, Anil Mishra from Intergovernmental Hydrological Program, UNESCO. Just picking up after Jerome's, have you considered engaging citizens, or in other words, citizen science in the data collection process? Because after all these hazards are affecting local community, whether they are engaged in a validation process, now lots of scientific community are engaging citizens in this process, and if there is any education capacity development need in that direction as well. Thank you.
Thank you. In some places, I would say yes. For example, in France, there was a campaign of snow sample collection by citizens, which was organized during the last winters, most of all to document the deposition of particles within the snow. And I know another initiative like this in Chile, which is called the Vecinos de la Nieve, the neighbors of the snow, or something like this. So this is emerging. On glacier, it's maybe a bit difficult because the environment is difficult, and so a reduced number of people go there, but it can be encouraged.
Yeah, it's interesting. We had some experience in the social cryosphere, the way that people perceive the cryosphere in the region, and how they adapt mainly against hazards, natural hazards. And some people have been working in the Santa Valley in Peru, near Huaraz, exactly examine the relationship between people and the glaciers and how former civilizations there, pre-Columbian civilizations have adapted themselves, not in building in the middle of the valleys that we have from time to time the alluvions, the floods. It is interesting that the sites are in protected areas and the modern cities are in the middle of the valley. Just wait for the next disaster.
Jerome says we can keep going because the next session is when the other two science sessions are coming together in this room. So if there are any more questions, there we go. There's one over here. You can have my microscope.
Thank you, and thank you all for your talk. It was really fascinating. So I had a question regarding some of the citizen engagement, because what's really interesting, and I run a project that tries to bring different stakeholders together from tourism across the Alps and other regions, and I think when we look at that relatability of many of these issues, bringing it back to the local community and the local economy, tourism is often quite an interesting kind of powerful link. So I wondered, how do we tap into that relatability for local communities and also for tourists that are visiting many of these places? Because the irony seems to be that many people go because of the beauty of the nature, many of the landscapes that you've shared, and yet I don't think necessarily tourists tap into that agency to protect those landscapes as much as they should be doing.
Who would like to answer that one? Tourism. Jefferson. No.
So what's your question? You mean because our project being in the future, when the glacier shrink, we probably also the slowline increased. It's caused the less attraction for the tourists. So. Oh yeah, sometimes we said, yeah, you see glacier without speed. Yes, let's go to see it. Otherwise, we cannot see it again. Yeah, that's sometimes. Yeah, I know some people think about that. Of course, within China, we have very strict tourist regulations because we never let the tourists touch the glacier, because if you tourists just climb everywhere and touch the glacier, that is really impacted the glacier. So that's true. But a lot of things, not only the glacier, but also the snow cover. Snow cover duration is shorter and shorter, so nature ski and those related tourists be the season shorter. So of course some place they use artificial snow for the ski. So that really definitely impact tourism.
Thank you for all of the science presentations. I'm not part of the science panels, so I found them really helpful. But what I've been very interested in, and this is maybe going on the next bit after your panel presentations, you've been talking also about your declaration or your statements about I think someone referred to this morning, I think, 14 pages of things that you wanted to see. And well, I'm just curious, one thing we have not heard a lot about as part of the why, we've heard about, in this panel, for example, the implications for water supply, and we've heard in other panels implications for sea level rise. But I haven't heard anything really about ecosystems or the natural world. And I'm just curious as to whether you've got statements about those other topics that we just haven't heard about in these panels, perhaps. And maybe that's just going to be at another session that we haven't got to yet. So I'd just like to hear more about that. Thanks.
There are discussions about ecosystems, but they're in the polar context, because this is a conference about polar and high mountain glacial environments. So there's not so much discussion about tropics per se, but there is discussion about ecosystems in the other session, which is looking at sea ice and ocean, where there's a lot more interaction with ecosystems, nutrients, and animal life. So that was in the other session. And so what's going to happen now actually is the people that have been in this, particularly the speakers that have been in the session on sea ice, ocean and ecosystems, plus the people that have been in the permafrost sessions, because there have been 3 parallel sessions, they will all come in here and we'll have a summary. So hopefully there will be some mention of ecosystems in a moment.
And there was also a talk in the previous session, so a presentation by Jean-Baptiste Bosson, and in the panel there were people from national parks and IRD and NGO and things like this. And so they discuss a bit about this.
Maybe I can comment a bit about the declaration, but I don't remember exactly how it was written, but we have something related with new areas being deglaciated and how we should treat them, because there are going to be new ecosystems developing there. Do we want to see invasive species? How do we invent a new regulation to protect this kind of areas? So that's part of the message we want to convey to the heads of state, because that's something which could be handled internationally and not just regionally.
Yes, and following on from what Jerome said, I remember a few years ago there was a long discussion in the Antarctic community because there were large ice shelves breaking apart, the Larsen ice shelves on the Antarctic Peninsula, and there was a large area of seafloor that was exposed for the first time in human history. And so there was a discussion about whether those areas should be protected from fishing, tourism, or any kind of intrusion by ships or things like that. So it's not an area most people go to anyway, but it was quite interesting that that was discussed at that point. Jerome?
Thank you. I get on the topic which is a bit sensitive because you mentioned it. You spoke about artificial snow. And we know that there are projects, kind of geoengineering at local scale. Let's increase the albedo of the glacier just before the melting season. We put carpets, and that's a source of plastic. We put artificial snow, and we wonder about systemic approach. What about the carbon footprint of this approach? Do you have any comments to do on that? Because, we hear, including from Elysee, everything you say, this is desperate. So give us hope. And they think about, magic solution. And one magic solution we've seen, especially in the Alps, in the Austria, for instance, these people who have put carpets on glaciers, on some very tiny parts of glaciers to protect them. And so would you like to comment on this topic?
Solution? Okay. Yeah, do you want to? Okay. Dark regions, the local villages, they already start doing the adaptation. So during the summer and autumn, they have the small tunnel to build. They also first build the dam, then take the water to be frozen in this small pool. And in the spring, the lower elevation means village compared to the glacier areas. The village areas, the frozen ice, so-called artificial glacier, melt. Then the village can use this water during the irrigation and as a daily water resource. So that also means if in the future the glacier as a solid reservoir of water resources, if they disappear or shrink, then people can build up artificial glaciers, especially that we collect the waters in the summer and autumn during the monsoon season, and they're frozen, used in the next spring. So that's one adaptation way. Of course, for the solution, probably we have how to protect glaciers, especially for some glaciers which are very valuable for tourists. We can make the cover to protect it. So recently we did a test experiment that if we cover the glacier in the small areas, we can save the mass, well, 1/3 of the mass. So that's another way. If for the river basin, probably we can doing the artificial slowing. We add slowing frequency so that we can increase the glacial albedo, so make the glacier whiter to reflect the solar radiations. So that's another way.
Okay. Thank you very much, everybody. I think the other sessions are now finished and coming in. So let's thank our speakers in this session, which was a really fascinating and very, very different focus from this morning from the polar regions. So thank you very much to speakers.